So in this problem, we want to simplify, perform the indicated operations and simplify. So here we're going to subtract these two rational expressions. Um, in order to do that, we need a common denominator. And to find a common denominator, I want to factor the first fraction. So x cubed minus 8. Remember that x cubed minus 2 cubed, that's a difference of cubes. And the difference of cubes, a cubed minus b cubed, factors into a minus b times a squared plus ab plus b squared. Okay, so x cubed minus 2 cubed will factor into x minus 2 times x squared plus 2x plus 4. Minus the other fraction is 3 over x minus 2. Now, of course, looking at these two, we see that the LCD is actually x minus 2 times x squared plus 2x plus 4. So the next expression is going to be both of these fractions with that LCD as both denominators. So this is x minus 2 times x squared plus 2x plus 4. And same thing here, x minus 2 times x squared plus 2x plus 4. Now, the new numerator is going to be negative 6 times the missing. We're going to compare the missing factor of the old denominator, which is right here, to the new denominator. And we see that there are no missing factors, so this just doesn't change. It just multiplies by 1. And similarly, we're going to compare the old denominator for this fraction to the new one, and we see that the missing factor is that big trinomial. So 3, which is the old numerator, is multiplied by x squared plus 2x plus 4. So in this next step, we can have a single fraction because we have a common denominator, which is just x minus 2 times that trinomial. And we have negative 6 minus the quantity 3x squared plus 6x plus 12. And if I remove the fraction, if I remove the parentheses, then we have, okay, so the denominator doesn't change. Let's write that first. The numerator will be negative 6 minus 3x squared minus 6x minus 18. Combining like terms, we get negative 3x squared minus 6x minus 24 over x minus 2 times x squared plus 2x plus 4. And then we can actually factor the numerator to see if possibly anything would cancel. So negative 3 factors x squared plus 2x plus 4 over x minus 2 times, there it is, look, it does cancel. The second trinomial is a common factor. It cancels. And so here the final answer would be negative 3 over x minus 2. For this next problem, again, we're going to multiply these two and then simplify. So 4 times square root of 3 times square root of 3 is 4 times 3. The next factor is 4 times 5 is 20, plus 1 times square root of 3 is square root of 3. Oh, we're missing a square root of 3 here in the second factor. So let's do that again. 4 square root of 3 times 5 is actually minus 20 square root of 3. There we go. And then this term is plus 1 square root of 3, and then finally minus 5. Okay, so here we get 12. These two combine because they're like radicals. Get negative 19 square root of 3 minus 5. And then this term and this term combine. They subtract to give 7. 7 minus 19 square root of 3. And that's the final answer. So let's take a look at the next page. So here we want to simplify the expression, write the answer with positive exponents, and we can assume all variables represent positive numbers. Okay, so the first thing we're going to do here is we're going to use the power rule and the quotient rule to make both the numerator factors and denominator take on an exponent of 3. So we have 2 to the 3, p to the 2/3 to the 3 over x to the 1/4 to the 3. So here you can see that this exponent of 3 acts on every factor inside the parentheses. And let's do that for the second piece as well. So here in the second piece, the exponent of -2 is going to act on both factors in the numerator and denominator. So we would get p to the 1/3 to the -2, x to the 1/8 to the -2. And so we see here that this exponent acts on both of the factors. This is the quotient rule. Alright, so let's actually work these out. In the first fraction, we have 8. And then here, when you have a power to a power, we're going to multiply these. So 2/3 times 3 is 2. So that's just p squared. And similarly here, we have x to the 3/4. Next, same thing, we're going to multiply the exponents. You get p to the -2/3, and here you get x to the -2/8, which is -1/4. And then here we have multiplication. Multiplying the numerators, 8p squared, p to the -2/3, and x 3/4, x to the -1/4. Now here, focusing on this product of the p's, we add the exponents. So we would get 8p, and then 2 plus -2/3 is 6/3 minus 2/3, so that's 4/3, over x to the power of 3/4 plus -1/4, which is 2/4 or 1/2. So x to the 1/2. And all exponents are positive. And so we leave the answer as is. That's the final answer. In this next problem, we're going to use the properties of logarithms to express the logarithm as a sum or difference of logarithms and express exponents as factors. So here, we're going to look at the numerator and denominator and use the quotient rule to write this as a difference. Log base 5 of cube root of 18 minus log base 5 of xy squared. Next, we can just rewrite this as a power. So this is 18 to the 1/3. And this is a product here. So the product inside the logarithm changes to a sum of logarithms. Notice the bracket here because the minus is about to distribute. Log of x plus log base 5 of y squared. Now, we're going to do two things. First, we're going to distribute the minus sign, and we're going to use the power rule to bring these exponents as factors. So we would get 1/3 log base 5 of 18 minus log base 5 of x plus 2 log base 5 of y. Now we made a mistake. This is a common error, forgetting to distribute the minus sign. This minus sign needs to distribute. And that's the final answer.